Okay, we're getting near the end of our word problem section here with linear systems. I'm assuming that you all know this distance, speed, time triangle and how to read it. So distance is equal to speed times time, speed is equal to distance over time, and time is equal to distance over or divided by speed. So here we have two scenarios. Tyler is going downstream and then he's going upstream. And they want to know what his average rowing speed is and what his average current, the average speed of the current is. So I want to ask you something. I'm hoping that you can envision this. If you, or I'll just make up the numbers, if you are rowing 10 kilometers an hour downstream and the current is moving at 2 kilometers an hour, I hope you can see that your boat would actually be moving 12 kilometers an hour. It's being paddled 10 kilometers an hour and is getting pushed along by the current an additional 2 kilometers an hour for a total of 12 kilometers an hour. Now, when we're going against the current, let's say it's the same speeds. You're going into the current with a speed of 10 kilometers an hour, but you're being pushed back by the current 2 kilometers an hour, which means you end up with 8 kilometers an hour of your actual speed. Okay, so let's take a look here at distance, speed, and time. And we're going to make a little bit of a chart. There's going to be the downstream, and there's going to be the upstream equation. So let's see here. Tyler rows 10 kilometers downstream. So we know kilometers is distance. And it took 2 hours. And on the return, when he went upstream, it took 4 hours. And he had to only travel 8 kilometers. He didn't go all the way back. So we need to figure out the average rowing speed. Now, as I said earlier, when you're going downstream or with the wind in an airplane, you're going to be adding the speed of the rowing, in this case, plus the speed of the current. And when you're going upstream, you're going to have the speed that you're rowing minus the speed of the current. So if we're going to do our let statements and let R be the rowing speed, so let R be the rowing speed, and let C be the speed of the current, then downstream speed is going to be speed of the rower plus speed of the current, and upstream is going to be speed of the rower minus speed of the current. Okay? Now, we know the relationship between these three is this. So we know distance equals speed times time. So I'm going to write that down. Seeing as distance equals speed times time, I always curl my T, otherwise you're going to find, you're going to maybe make a silly mistake, and you're going to think a T is a plus sign, and you'll make some silly arithmetic error when you're simplifying. So here, what I'm going to do is I'm going to write this equation, and then I'm going to write this equation. So D equals S times T, and D equals S times T. Okay, that's equation 1, and that's equation 2. Now, I can divide both sides by 2 here, and I can divide both sides by 4 here and simplify. So I'm going to do that. Equation 1 divided by 2. So 10 divided by 2 is 5, and this divided by 2 cancels that, so we just have R plus C. For equation 2, I'm going to divide both sides by 4. So that divided by 4 is 2, and this divided by 4 is R minus C. And then you have two equations similar to what you're used to looking at. If I subtract these, I'll get rid of the R, because the signs are the same. And if I add these two equations, I'll eliminate the c because the signs are different. Now, do I want to know both? Yeah, I want to know the speed of the boat and the rowing and the current, so it doesn't matter. So let's say I'm going to add them and get rid of c. So I'm going to take equation 3 and add it to equation 4. So that plus that is 7, that plus that is 2r, and that plus that is gone. So r, divide both sides by 2, so r is equal to 7 over 2. r equals 7 over 2, which is the same as 3.5. Of course, you would never say he rode at 7 over 2 kilometers an hour. We're going to say how we would say it. We would say 3.5 or 3.5. Okay, so now I'm going to sub that into equation 3 to find out what c is. So I've got here 5 equals r plus c, but r is 3.5. So c is going to be, so I've got 5 minus 3.5 equals c, and c equals 1.5. And then our sentences are, or our sentence is, the average rowing speed is 3.5 kilometers per hour. Don't forget, this is kilometers. This is hours, and this is kilometers per hour when you look at the units. Okay, there's no need to put units in here. Units just in your final sentence. So the average rowing speed is 3.5 kilometers an hour, and the average speed of the current is 1.5 kilometers an hour. Okay, so now let's take a look at this because it's the exact same thing. We have a plane. It's going with the wind and against the wind. So what I want you to do is exactly what we did up here. With the wind, against the wind, DST, and get going on that question. And here, notice, they only asked for the speed of the wind, and I'm letting you know right now that the wind speed is 80 kilometers per hour, so go solve that question and make sure that's what you get.